All right, there we go. Okay, today, here's what we're gonna go through. We're gonna finish up our PowerPoint that we did the other day. That was the 1.6 PowerPoint on the different types of polygons. We're gonna talk about circles today as well, the conic sections, and then at some point today we will get to homework. So that's kind of what you can kind of expect. But again, we're gonna finish up section 1.6. This is the last day of chapter 1 material. I know there's a section 1.7, but we usually cover that at a later date and come back to it when we need it. But for right now, our goal today is to go through this PowerPoint and make sure that we hit the different types of classification. So I know we talked about triangles on Friday. If you're gone Friday, that video should be online. I think as of this morning, it should be online. It'll be on the website today at some point, but it's on YouTube, but I'll post it to my website. But our goal today is to walk through the quads, the quadrilaterals. So we'll try to get through that today. But again, so our goal is to get through triangles and quads to make sure that you understand them, that you feel comfortable with them. Quads, quadrilaterals. I'm gonna introduce. After that, we're going to introduce circles and the conic sections, because circles is a big part of geometry, but it's not. Well, you got to remember, circles are not polygons. Polygons have straight edges. Circles have curves. It's part of conic, but it is a major part of geometry. So I do want to introduce it just kind of now, and then our goal today is to finish with what area and perimeter is. And I want to discuss those two objects today, especially for the shapes we have. So that's kind of what we'll get into. Okay, is there any questions with what we're doing today? Pretty straightforward. If we get a chance, say we will have homework, and the homework will be due way later this week. It will not be due tomorrow by any means. Like if we get to the homework today, I'll assign it for Thursday. So it's pretty straightforward. It's basically look at a picture, tell me what type it is. That's really what it is. It's pretty straightforward. But it'd be due on Thursday this week. Okay, let's jump right in. Let's start going through this PowerPoint here. All right, so let's see if the projector will let me do that. There we go. Okay, so we talked about polygons. You know, this is the definition where you draw the segments. Segments had to be connected to endpoints, couldn't cross each other. Main word we talked about was a vertex, and the sides were called edges or segments. The big thing about polygons is that they're segments. They're straight, okay? Then we talked about the types. I know today when you're looking at your pictures and you're labeling what your answer is, okay? Like when you look at this one particular shape, let's say something like this. What type of shape is that? So, like the classification of it. Is it a triangle? Is it a quad? Is it a pentagon? What is it? So, when you look at that shape, what size is it? All right. How many walls are there? 4. So, what type is that? Quad. So, you'd have to tell me it's quadrilateral. So, you got to know your types. So, quadrilateral. And the big thing is, now that you know it's a quad, it's also convex. The reason why it's convex, it's open on the inside. It doesn't have a cavern. You know, if you want a 4-sided figure that has a cave to it, a cavity, it would be this shape. There's a cavity to it. It's indented. That's a concave picture. So you're going to have to tell me that. So you have to tell me the classification and type. And then the idea is that on this shape, you also have to tell me if it's a regular or irregular shape. By regular, are all 4 walls the same size? Are all 4 walls the same? No, so it's irregular. That's the idea. So that was a term that we need to talk about today. We're actually going to get that at the very end today. But does everyone understand like the majority of your homework today? It is super easy. If the homework takes you longer than 10 minutes, you're probably doing something wrong today. Okay? So because of that. I think the hardest problem will be like find area, and that's a simple formula where you just take 2 numbers and you multiply them. So it's pretty easy homework. All right, any questions, comments, concerns so far? Okay, but again, this picture's convex. I know this is the book definition, but the idea is that if you can draw a line connecting two interior points and it crosses the outside, it's automatically concave, okay, or non-convex. And I told you how to draw that, but this is the idea. You're going to have to label it, tell me if it's convex, if it's regular or irregular. Okay, the different classifications, because you guys were really shy earlier: triangles, quads, pentagons, hexagons, heptagons, octagons. For seven-sided, I want heptagon today. That's the one I want. That's the traditional one that I think your book has. Okay, nonagon is the one I want for 9. Decagon, hendecagon is the 11. That's the one I want. And then dodecagon. These are your options for your pictures today, as well as a circle. But circles are pretty straightforward. So, any questions on that? Okay, I know on Friday we talked about the different types of triangles. So I'm going to go through that slide really quick, just blitz through it. Then we have to hit the quads. There is 6 types of quads that I want to discuss today. Okay? All right, so let's fire away. Triangles, remember, it's classified by the number of walls. That's how I know which name it is. So when you look at a picture, triangle means 3, so it's got 3 walls, so it's triangle. It's got 3 sides, 3 vertices. How we classify that triangle, again, is by its side lengths or by its angles. That's where the names come from. So the first 3 names, when you look at a triangle today, and when you have a picture of a triangle, you have to tell me what type it is. That's a big deal when you're in your homework. So it's not just the idea of like, tell me it's a triangle and it's convex and and it's irregular. You might have to tell me what type it is. So it's scalene or it's acute. That type of thing. You always have to use 2 words for every triangle. So the types by its side lengths. If no walls are the same, it's called scalene. So it's just a regular picture. You can notice that the 3 walls are of different sizes, or they just don't have any markings. So it's scalene. A lot of pictures, like a ton of pictures, are always scalene because they don't have any markings to them. Okay, isosceles is when 2 walls are the same. Okay, this picture, even though 2 walls are the same, these 2 pictures right here are still considered irregular. The reason why regular is this one. Regular means the 3 walls are the same and the angles are the same. So it's equilateral as well as equiangular on this picture anyway. So that's a regular triangle. So that would be the equilateral. Okay, any questions with the first 3 words? Again, this PowerPoint is online from Friday. I know it's online, I already checked. Okay? All right, next, we talked about how to classify triangles by its angles. We had acute triangles. That's where the angles are smaller than 90, very obvious when you look at them. We had a right triangle where one of the angles is exactly 90. They'll usually put the box in the corner. And then obtuse is where one of the angles is larger than 90. How you compare? You turn the book and you try to put the big angle in the corner so you can see it's past like an L shape. It's past this. That's how I can tell. Okay, and again, you have to pick one of these words and one of these words when you classify a triangle. It's always 2 of them. So it's one of these, one of the others. Okay, any questions with the triangles? Okay, those are the ones we did Friday. All right, new stuff today. We have the quads. So I'll make the lights here. Okay, so quadrilaterals. Again, you classify the polygon by its number of walls, the number of edges, sides. Okay, so a quad meaning 4. That's the root word there. That's a random 4-sided figure. Okay. The big thing is when you look at that picture, it's got 4 walls. It's got 4 vertices. That's the idea. Okay, and they label them. Okay, now the problem is when most people look at pictures of quads, they only have like 2 names in their heads. They think squares or rectangles. That's all they think of. There is 6 types of quads. Okay, this is the generic one. When you just see a random 4-sided figure, you have to call it a quad, unless they have specific markings making it one of the other. That's the main thing that people get wrong. Okay, so how you the main 2 categories of quadrilateral, and these are the ones that most people don't even think about. Like most of you probably maybe not even know these names. The main 2 categories of quad, if it's special. It doesn't have to be, but if it's special enough, it could be a parallelogram or a trapezoid. That's if it's special. If it's random, it's just a quad. it's not like a triangle where you are forced to give it two names. Quads can just be a quad. Maybe it doesn't have a subcategory to it. But if it's special enough, it'll fit one of these two categories, which are, okay, so raise of hands, how many people recognize these names? Okay, so you've at least seen them, okay? We need to still go through the definition, like what makes that special? Why are these two things unique for a four-sided figure? And then these two names will eventually branch into the other names that you guys are more familiar with, okay? So let's start with the definitions of these two words, and then what we'll do is, once we get through the definitions of what these are, we'll go more in depth into, like, I'll break down the parallelograms into their categories, and then I'll go to trapezoids into their own categories. Okay, and that's where we'll try to finish up with the trapezoids. Those will be my last category. Okay, so any questions, comments, concerns so far? All right, perfect. So the quads, right? Two main types. The first one's called a parallelogram, right? The main image I have of a parallelogram is like the pink pearl eraser. That's that little eraser you can buy in, you know, Staples or Target or Walmart. The actual outline is a parallelogram. It's the shadowed side right here. Okay, it's still four-sided. It's a four-sided figure. Now, what makes a parallelogram special, okay, is that both sets of walls, the top, bottom, and the right and left, those are parallel to each other. So they say in the book, according to the definition of the parallelogram, the opposite sides are parallel. Well, duh, that's where the name comes from. It's called a parallelogram. Okay, so do you understand that both pairs have to be parallel? Parallel means that they don't intersect. You know, they don't touch. They're equally spaced. The actual true definition of parallel is that they're on the same flat surface, which they are, and they're non-intersecting. Those are the two main parts of parallel, according to geometry. Okay, so that's a parallelogram. Now, the other type, which was, I think, what we called it the trapezoid, this has a slightly different definition. Now, the image I have in my head is like a skateboard ramp. It's kind of, or like a wedge. Like a door wedge that you put in like a door frame. The main difference between these two is that trapezoid only has one pair of sides are parallel. So when you look at that picture, you can see like on this picture, only the top and bottom are parallel. Just one pair. Now this is special. Like not every four-sided figure will have this where the walls are parallel. Okay, now I do want to give you a marking so you know if like, are they giving you walls that are parallel? So if you have certain walls being parallel on a picture, here's how they'll show it. So whatever that shape is, they're going to show it with little arrows like that. That means those two walls are exactly parallel to each other. And if there's another pair, they'll maybe double mark those to show you that those walls are parallel to each other. Okay? It doesn't mean they're equal. It just means they're parallel to each other. We'll learn a ton of properties about parallelograms eventually. I believe it's chapter 4. And, I mean, there's quite a few. I mean, I can think of like 4 main properties from a parallelogram right now, just off the top of my head from previous years. Okay. Does everyone understand the parallel symbols now? And I know like earlier, we always had, you know, in the first couple sections, you know, when you had two walls are being parallel, you know, whatever the walls are, we always use this symbol for parallel. Now, this wall is parallel to that wall. That's the parallel symbol for like sides. But on a picture diagram, they use these little arrows. That signifies it. Again, the railroad tracks means parallel. Okay, now what we're going to do is now that we've got the basic definitions here, we're going to break these down and look at specific types of each. So far, quads, you have 2 words. If it's special enough, it could be a parallelogram or a trapezoid. Okay, but let's jump into a parallelogram, and we'll look at the main types here. Okay? Okay, so parallelogram, opposite sides are parallel, but here's the subcategories to them. Okay, number 1, the first category, it could be a rectangle. Okay, that's a subcategory of a parallelogram. Okay, what makes this a parallelogram? Okay, it's still a 4-sided figure. The opposite walls are parallel, So those are the first two parts of it, the definition of a rectangle. And, more importantly, it has 4 right angles. That's the definition of a rectangle. So I'll say that again. The definition of a rectangle is 4-sided figure, opposite walls are parallel, and 4 right angles. Now, do you notice this picture? What else can you tell me about a rectangle by looking at this picture? What do these markings mean? What's something else that you know about a rectangle? Other than having 4 right angles and the walls are parallel. Sides are equal. That's a property because of the walls being parallel and we have the right angles. But again, the definition is a 4-sided figure, the walls are parallel, and it's got 4 right angles. That's what makes a rectangle special. So there's a lot of stipulations there to meet this category, which is what most people think a 4-sided figure is from the first place. That's a special type. Okay. The second category is called a rhombus. Okay. A lot of people look at that and they think of diamond. It's kind of like a diamond. Okay. What makes a rhombus special? Okay. It's got 4-sided figure. The walls are parallel, and the difference between these two is that a rhombus has 4 equal sides. The walls are the same. So in fact, I probably should have had the marking here. These 4 walls are exactly the same. Notice it didn't say anything about the angles. It didn't. It just said that the 4 walls are equal. Okay. Any questions with the 2 subcategories so far of a parallelogram? There's one more subcategory. It's when you mix these 2 together. What happens when you mix a figure with 4 right angles and the walls are being the same? What kind of shape is that? Where the 4 right angles and all 4 walls are equal. Square. That's the weird, like, love child of those 2 things put together. Okay? You mix a rectangle and a rhombus together, it makes this category right in between them, which is the square. And I noticed that on this picture, this is how they denote squares. They usually try to put 90-degree angles in the corners, but I forgot to do that. But they just say like 2 walls are the same, so it kind of makes it a square. So that I just use little A's. Okay, but those are your 3 subcategories of a parallelogram. But the square is a mix between a rectangle and a rhombus. It has all the definitions. 4-sided figure, walls are parallel, 4 right angles, 4 equal walls. That's a square. Okay, that's parallelograms, branch. Okay, now, if we go to the next category, which is the trapezoid. Okay, the trapezoid. The definition of a trapezoid, remember, is 1 pair of sides are parallel, just 1. So again, there's your picture, the one I gave you earlier. Now, there's only 1 subcategory to a trapezoid. Only 1. The subcategory to this thing is an isosceles trapezoid. Okay, so what does isosceles mean from before? Exactly. That's actually the picture. It's a trapezoid where you have 1 pair of walls are parallel, so I put little arrows here, and then the other pair are equal. So you can see that. The most common like architectural design for a trapezoid is this isosceles. If you think about like the step pyramids in Egypt, or the Mayan temples, or the Aztec temples down in Mexico, they use a isosceles trapezoid in design, where the actual steps are built with isosceles, and what they did is they just stacked little ones on top of each other until they made their temples. The reason why the structures really sounded safe, they moved away from doing huge pyramids, like the Pyramid of Giza, which is massive, right? Because if you ever took a look at the Pyramid of Giza, the top is still like it's brilliant white. It's limestone. It's coated in limestone. The whole pyramid used to be, but Egypt suffers from really bad sandstorms, like incredible sandstorms where it's like the winds are, 160 miles an hour sometimes. I mean, you can literally burn your skin off with sand. And what happens is when these pyramids get hit, it literally stripped all the sands, the limestone off of these things. And so what they did, and the problem was during a sandstorm, grave robbers would always go into a pyramid and rob it, and then they'd leave in the cover of a sandstorm. So what they did is they chopped the top off, and they went to a step pyramid later, because during a sandstorm, which can be a couple hundred feet tall, you wouldn't see the pyramid anymore. You wouldn't know where you're walking. Because before, the Great Pyramid of Giza is so tall, it literally sticks out the top of the sandstorm, so you can see it no matter where you're at. So you have a direction to walk. So it's an architectural thing, and then the Mayans continued that same setup because it's structurally sound. It doesn't collapse. It holds up way longer. It doesn't deteriorate as fast, I should say. Okay, so those are the different types of trapezoids. I'll show you a picture, or maybe I'll post a picture of the website so you can kind of see the step pyramids versus the Great Pyramid of Giza. I'll show you a comparison. Really kind of cool architectural designs. Okay, any questions with the quads, the different types? Parallelogram had those subcategories. The trapezoid has its own subcategory. Okay, now again, isosceles, one pair of opposite sides are parallel, the other sides are congruent. So, and they have to be different sets. Can't be the same set, because that would make it a different shape. Okay, now I have this little thing. I know this is silly. This is I call it the waterfall chart. So when we start learning properties in here, eventually, like chapter 4, I'll bring this chart back up on the board. This chart shows you when we start learning properties about just generic quads, the properties flow down the waterfall. It's like water flows down a waterfall, so do the properties. So when we start learning generic properties about quads, like how to find area, those flow down the chart and apply to all the ones below it. So when we start learning properties about parallelograms, those properties apply to all the ones below it, the rectangle, rhombus, and the square. And then when we learn properties about a trapezoid, those properties about a trapezoid that are unique to that shape flow down the chart to an isosceles. So the idea is that at the bottom photos pool all the different properties together. That's like the visual that I have. So when we start learning this, a lot of people always forget, like, oh, hey, yeah, we learned like 2 weeks ago, about parallelogram, that, certain angles are the same. Well, that's the same with the square. Certain angles are still the same with the square because it's still a parallelogram. The properties flow down. So you got to remember that they all apply downwards. They don't go up. Okay, is that like a visual that you can have? We're going to bring that back up and start using properties. You can understand like where they're going to go next. Okay, that's the end of the PowerPoint. Now the one thing I do want to talk about is let me get rid of this. I want to talk about the circle. Circle is not a polygon. A circle is a conic section. So I do want to discuss kind of the main purpose of a circle, right? So circles are part of a conic section. Conic sections is basically a big fancy term for they're pieces of like a cone. So if you had an ice cream cone and you took different slices of it, like you took like a bandsaw and you cut it off in different pieces. The idea is that you would get different types of conic shapes. So like for instance, when you look at an ice cream cone straight on, like head down, and there's no ice cream in it, what type of shape do you have there? What is that shape? It's a circle. It's a perfect circle. That's an ice cream cone, right? It's a perfect circle top down. In fact, it has a point in the middle, which is the center point. It has a radius, which is this distance. The radius is the most important thing. If you have the radius, you can find area, you can find distance around the object, you can find diameter, that type of thing. So the radius is actually an important number, okay? But that's a circle, right? We'll come back to that here in a second. If you were to take a bandsaw and cut this off at a weird angle, like you cut like your bandsaw this way, so here's your saw, and you cut it off diagonally, what would happen is that this would be your shape if you looked at it from like top down. Well, what type of shape is that? What type of shape is that? Yeah, it's an oval type shape. We call that an ellipse. Ellipse, which is an oval. That's just a big fancy word for it. Okay. Ellipse or oval, they have their own set of properties to them. You know, but again, ellipse is based on a circle. It's just a stretched out circle. But that's if you cut it off at an angle. You can actually see ellipse if you were to take like a perfect circular shape, like a penny, and you look at it at a different angle. So you look at it like this direction versus straight up and down, it would give you that ellipse shape. It would give you an oval because it's an optical illusion. Okay? If you were to cut the ice cream cone straight down, so here's your ice cream cone, and you were to just take a bandsaw and cut this way, and or take a bite out of it. You take a bite out of the cone, or you cut straight down through the top. This is the shape you'd see in the front of your cone. So here'd be your cone, right? And you were to cut a bandsaw straight down. This would be the shape. That shape is called a parabola. Parabola. It's a U shape. Most people think it's because of the bite you take out of your ice cream cone. That's what gives it the shape. It's not. Your mouth is a flat plane. And when you took a bite out of it, it's just taking a straight edge right out of the cone, and it will always give you that shape. It's not your mouth doing it. So that's a parabola. If you had two cones put together, you can make a hyperbola. There'd be two of them back to back. But these are the most common types of conic sections. Eventually this year, our goal is to kind of talk about each of these separately. Eventually. That'd be like end of the year type of thing. But today, we need to focus on the circle. That's the one I want to hammer down today. Just make sure you know the vocab terms, you know what we can use it for. All right. Any questions, comments, concerns on anything we've talked about today? I know it's kind of give you a crash course in all these different shapes. Okay, so first thing let's talk about the triangle. Okay. How many different names do we have for triangles? How many different names do you have? 3 and 3, so a total of 6, unless you use like equal angular or regular. So we have 6 different names we can use for triangles. They all share the same property though. Triangles, you use the same area formula to find area, or the same perimeter formula. Let's talk about perimeter first. Anyone know the definition of perimeter? Or how do you find perimeter for an object? Okay. Anyone have an idea for perimeter? Yeah, add the walls, right? So no matter what the walls are, let's say it's 4 centimeters, 7 centimeters, and 8 centimeters, right? This is an irregular triangle, so it's scalene. Right? So it's a scalene triangle, the 3 walls are different. Perimeters, you just add the walls together. So it's just the distance around the outside. So 4 plus 7 plus 8. And you can get that number, right? What is that, 19 centimeters altogether? That's perimeter. We use the word perimeter for polygons, things with straight edges. That's the distance around the outside. For area of a triangle, area is the number of square units in the object. It's different than perimeter. Perimeter is like a fence around the object. This room has a perimeter, the wall lengths, right? But area is the number of square tiles on the floor of it. Like little 1 by 1 centimeters going across, that type of thing. Okay, to find area for a triangle, this is what you do. You take the base of the triangle, so that's the 8. You take it times how tall it is, that's the height. Well, here's the thing. When you look at this picture, you don't have height. You don't have it. So I'm going to say that this height here going this direction, even though these numbers don't make sense, let's say that this height is let's say it's 3 centimeters. Let's say that's how tall it is. Okay? That's the height. Height has to use altitude. So use a 90-degree angle. Go up and down. You take base times height, so 8 times 3, and then you cut that number in half. Whatever that is. You divide it by 2. That will give you the area, the number of square tiles in that object. Okay, so does everyone understand how to find area for this? So on my problem, I would take 3 times 8, and you cut that number in half. So 3 times 8 is 24, you cut it in half, what is that, 12? And the and the label is centimeters squared. It's squares. So you always have to, whatever your label is, you square it. That's how many little squares you have, 12 little squares. All right, any questions with how to find perimeter or area for a triangle? Pretty basic. I think most people know that from like elementary days or junior high days. They learn that type of stuff. I remember learning that in like 5th, 6th grade for the area of a triangle. But I want you to know those terms. Because some people like mix them up. They just don't understand that. They don't understand what perimeter means versus area. They're two different things. Perimeter is the distance around, area is the number of square tiles in. What about a rectangle or square or a rhombus or a parallelogram? How do you find area of this thing or perimeter of this thing? Let's talk about perimeter. What is perimeter again? Yeah, so it's the distance around, right? So if it was 5 centimeters and 10 centimeters, and 5 centimeters and 10 centimeters, right? The total perimeter here is you add them up. And that would be 30 in this case, so the answer would be 30 centimeters, right? But how do you find area, though? Yeah, base and type. That's actually why the triangle has their area formula. Is you can actually see that you can take it, you can find a triangle of a rectangle, right? You take base and type, so 5 times 10. So 5 times 10, and that would be 50 square centimeters, or centimeters squared, whatever you want to say. Like, notice the difference in labels. But again, that's how they actually came up with this formula. That you can make any, you find the area of a triangle because you can always make a rectangle and then cut it in half, and that makes the triangle. That's the idea. That's where the formula comes from. Okay, now for a circle, it's different, right? It's the same formula if you have a parallelogram or a rhombus or anything. But for a circle, you have to use the radius number. And we don't use the word perimeter. We use circumference. Because it's not a polygon, so you can't use the same terminology. It's a different object. So we don't use perimeter, we use circumference, the distance around it. To do that, you take 2, the number 2, times the radius, so whatever that radius is, you double it, and then you take that times pi. And that gives you the circumference around that object. So somebody can just make up a number for a radius. Anything, say? 3. So let's say that's 3 centimeters, right? So you take 2 times 3 centimeters times pi. So the correct answer is if you take 2 times 3, that's 6 pi centimeters. Right? That's the exact answer. Now pi is on the border there, it's 3.14, blah, blah, blah. You take 6 times 3.14, you get around 18 something. Okay, so it's about 18 centimeters. That's the distance around that object. Okay, this is the exact answer, but if you want decimals, you have to take 6 times 3.14. Okay, because I think of pi as like a variable, it's like an x or an n. Okay, but for area has a different formula for a circle. Area is pi times the radius squared. So if I use the same circle, I take pi times 3 centimeters squared. So 3 squared is 9. I take that times pi, and I get 9 pi centimeters squared. That's the area of the inside. That's the number of square tiles in that circle. Okay, which if pi is 3.14, so 3.1 times 9 is roughly 27.9. That type of thing. So 27.9 little square tiles in that object. Most people learn this stuff, I think, usually junior high. They learn circumference and what area is. Eventually this year, we'll discuss why. Hopefully we get to it because we have to talk about this stuff first. But we'll get to a circle like why is that the formula? Like where did they come up with that? That type of thing. We can give a little history lesson on that. But for right now, does everyone feel comfortable like the generic stuff that we've done before you walk in? Because sometimes this easy stuff is stuff that some people forget from previous years. It's like a staple. It's one of the things we need to know before we can really start the hard stuff in geometry. Okay, here's your homework today. Pretty easy. What you're going to do is you're going to look at a picture, tell me what type it is. So it's basically, oh, it's a quad, it's convex, it looks like it's irregular, or you can tell me what specific type it is if it's like rectangle or square or something like that. Okay, so here's your homework. It is page It is page 61. Page, jeez, that's terrible. Okay, so it is page 61. It is 1 through 8, 11 through 22, 29, 30. Those are the main ones I'm going to be checking. And then you have a couple challenge questions, which are these, 34 through 39. Remember, the challenge questions I don't really check, but I do want to see if you can figure them out. So 34 through 39 are the challenge questions for that second. Some of you are actually pretty good at these challenge questions. I'm starting to figure them out more. So it's one where you have to require some algebra skills. Okay, any questions with that? That is due this Thursday, which is the, what, 22nd? This Thursday, 22nd of September. Okay, so right now you need to memorize kind of where you're sitting. Other than Ryan here about this. So memorize where you're sitting. I'll try to put up the scene chart again tomorrow. Remember, this Wednesday we don't have school. So Wednesday we do not have school. I think it's a PD day. So I know at some point today, juniors, seniors, you guys are going to be voting on homecoming candidates. They'll just vote for who the court's going to be. And then next Monday, Tuesday, the entire school votes on who the king and queen actually are. That's next week. I think they usually vote 6th period, but I think Ms. Fermonic, Lori, sent out an email this morning when you guys are going to vote. I think that went out this morning. So pay attention, check your email at some point today so you know when. Okay? All right, any questions, comments, concerns on anything we talked about today? This homework is super easy. Like if it takes you more than 10 minutes, you're doing something wrong. You're doing something wrong because it's, what is the name of that object? It's super easy. It's vocab truth. All right, there you go.